Have you ever noticed that vacation days go by twice as fast as work days? Well, maybe that's precisely what's happening. The Earth doesn't spin on its axis once in exactly 24 hours as we used to think. In fact, its rotation speed can change. On July the 19th, 2020, scientists recorded the shortest day in history. It was almost a millisecond and a half shorter than usual. Moreover, researchers believe that the Earth's rotation rate will continue to increase. But how fast? 4.5 billion years ago, the day on our planet lasted for just 4 hours. What if Earth starts spinning so fast again? In this video, you'll find out, can raindrops fall in the opposite direction? How to reach zero gravity on our planet? And what will happen to us if Earth starts spinning at the speed of light? At present, our Earth spins at 1,670 kilometers per hour. However, it's only if you live in the equatorial region. The closer to the pole we get, the lower the rotation speed. If your home is, let's say, Chicago, you spin on the axis of Earth at approximately 1,200 kilometers per hour. That's why, in case the rotation speed changes, the first people to notice it will be those living near the equator. For that, Earth needs to move only 1 mile per hour faster. If that happens, the water level in the equatorial regions will rise by about 5 centimeters. The point is, due to the rotational force, water will shift from the poles, so the ocean near the equator will become a couple of centimeters deeper, and an Earth day will be 90 seconds shorter. These changes will likely go unnoticed. But satellite signal loss may have profound implications. That's because the satellites that orbit as fast as Earth rotates may go off course. Satellite communication and everything related to it, including military operations and television broadcasting, will be just unable to function. But what will happen to us if Earth starts moving 100 miles per hour faster? It may have much more extensive consequences for the countries near the equator. The water level will rise by 10 or 20 meters there. Amazonia will be completely submerged, as well as most equatorial regions. Floods will reach even northern Australia. And a day will last only 22 hours. Consequently, people will constantly suffer from jet lag until their biological clocks adjust to the new conditions. By the way, this is how long a day was back in dinosaur times. So, it means that if Earth starts moving just 160 kilometers per hour faster, we'll be able to personally see what life on our planet used to be like during the Cretaceous period. Do you feel like looking further back in time? Let's make Earth spin 2 times faster. The water level near the equator will rise so high that some mountains of the Andes and Kilimanjaro will be the only objects to stay above its surface. On the contrary, the volume of water in the Arctic Ocean will decrease. The gravitational force close to the equator will get a few times weaker, while humidity will get extremely high. This means that if you feel like taking a peek at Kilimanjaro before it gets totally drowned, you'll have to tolerate thick fog and incessant rain. And an Earth day will last around 12 hours. That was about 3 billion years ago. So it turns out that throughout its history, the Earth was gradually losing its rotation rate. Something kept slowing it down. About 4.5 billion years ago, Earth collided with a large space object, and scientists believe it could be a protoplanet the size of modern Mars. After the impact, Earth started spinning on its axis even faster, at about 9,500 kilometers per hour. Back then, the day lasted for only 4 hours. As a result of the collision, part of the rock was separated from our planet, and the debris collected in orbit around Earth to form the Moon. Although it's almost 80 times smaller than Earth, the Moon's gravity force affected our rotation rate, and it still does. The rotation rate slows down by 6.1 kilometers per hour every 10 million years. Since the moon formed, Earth started spinning on its axis 6 times slower. But if the collision with the protoplanet never occurred, there would be nothing to slow us down. What if Earth, on the contrary, was speeding up all this time? If the moon wasn't slowing us down, it's entirely possible that people on Earth could be in zero gravity now, all because of centrifugal force that arises during the process of spinning. It's directed away from the center of Earth and compensates for the effect of gravity, or centripetal force. To end up in zero gravity, we have to make Earth accelerate its spinning by 17 times. Although there will be no more living humans on the planet spinning at such speed. Powerful hurricanes will be raging on the surface of Earth as they do on Jupiter. They'll be formed due to the rotation speed difference between the poles and the equator. Moreover, considering centrifugal force, raindrops will hover in the atmosphere or even move upward. A day will last 90 minutes. But what will happen to Earth if it spins on its axis in just 1 hour? To do so, the planet will need to move 24 times faster and reach the speed of 40,000 kilometers per hour. At this stage, a continuous series of earthquakes will happen on Earth because its tectonic plates will shift and the Earth's crust will smooth out at the poles and lift near the equator. Continents will bunch up and violent earthquakes will obliterate the traces of our civilization. But what if we add some extra speed? What will happen if we accelerate Earth to the speed of light? First of all, Earth will change its shape and shrink from the poles until it transforms into a thin disk. But the Flat Earth Society won't have enough time to celebrate that, as they'll get squished together with the planet. A day on Earth will last only 1/10 of a second, and time on the planet itself will stop. The centrifugal force will be so powerful that the Earth's crust will be torn to pieces and thrown into space. At the same time, the energy and mass of Earth will tend to infinity. Can you see where this is going? Our planet will turn into a black hole. Black holes are the only objects in the universe that can rotate at near the speed of light. After the transformation, the Earth will become a tiny black hole with a radius of only about 9 millimeters. For reference, if our Sun became a black hole, it would have a radius of about 3 kilometers. And the radius of the supermassive black hole in the center of the Milky Way would be 16 million kilometers. Humanity will have several options. We may be flattened along with Earth, or torn to shreds and catapulted into space, or get beyond the horizon of the black hole and disappear forever. It's a good thing a giant protoplanet once crashed into the Earth, and now we have the moon. It'll prevent our planet from speeding up to the speed of light and throwing humanity into a black hole. But what if one day the moon will make Earth stop spinning at all? In that case, one hemisphere will suffer from terrible fires and droughts, and the other will be plunged into an ice age. We'll have to team up and start a survival colony somewhere in between. Now the black hole option doesn't seem so dark to me. Write in the comments what you'd go for, and see you in the next video.